Okay, so today we're diving into one of biology's biggest mysteries, the biological clock. A really groundbreaking new study has given us this incredible window into what's actually going on inside an egg cell as it ages. So let's get right into it. I mean, we've all heard that term, the biological clock, but what is actually ticking? On a cellular level? If it is a clock, what are the gears? What part is actually winding down? Well, this is the exact question that scientists have been trying to answer. And the answer, it turns out, might just be hiding inside the cell's tiny, but, well, incredibly powerful little engines. The prime suspect in this whole mystery isn't some abstract concept of aging. No, it's something very real, something tangible. It's the mitochondria. All right, first up, the prime suspect, an egg's powerhouse. So let's meet the main character in this story, the mitochondrion. We're going to break down what they are and why they are so important for an egg cell. So you might remember this from high school biology, right? Mitochondria are often called the powerhouses of the cell, and that's a pretty great description. Just think of them as thousands of little batteries crammed inside a single cell, and their whole job is to generate the chemical energy that fuels literally everything the cell does to live and grow. And here's why this matters so much for an egg cell. That final step, when an oocyte matures and gets ready for fertilization, well, it's not a casual walk in the park. It's a full-on energy-guzzling marathon. The cell has to do this massive reorganization, correctly sort all of its chromosomes, and all of that takes an immense amount of fuel. And guess where that fuel comes from? What's absolutely fascinating is that scientists can actually see this energy production happening in real time. They use these special markers that make things light up. So the red dots here, that shows us all the mitochondria, kind of like a head count. But the green glow, that's the really important part. That only shows up where mitochondria are actively working, churning out energy. And just look at this young, healthy oocyte. It's practically glowing green, especially around the edges. That's a sign of a cell that's just brimming with energy. Okay, so if energy is really the key, what happens when you compare the powerhouses in eggs from different age groups? This is where the evidence starts to get really interesting. Let's look at the tail of two eggs. And wow, the difference is it's night and day. Seriously, look. On the left, you've got an oocyte from a younger woman. See how the mitochondria look bigger, more connected? They're forming this beautiful network. Now look at the right. This is from a woman of advanced maternal age. The mitochondria are they're fragmented into these tiny little dots. This visual difference is the first huge clue. Yeah, the researchers had the perfect words for it. In the younger eggs, the mitochondria are tubular. They're long and connected, which usually means they're working together efficiently. But in the older eggs, they become point-like, all broken up. And that's often a sign that things aren't working so well. So the big question is, does this visual difference actually matter? Does it affect what the egg can do? And the data says, absolutely. It matters a lot. Look at this. The oocytes from the younger group, they successfully matured over 86% of the time. That's great. But the group with advanced maternal age, that number plummets down to just over 62%. That is a massive drop in the ability to get that final, supercritical job done. Okay, let's just recap the evidence so far. On one hand, you have the young oocytes, lots of energy, nice connected mitochondria, and a high success rate. On the other hand, you've got the older oocytes, lower energy, fragmented mitochondria, and a much lower success rate. The link seems pretty obvious, right? But correlation isn't causation. Is the mitochondrial problem causing the failure, or is it just another symptom of aging? And this is the part of the story where we look for the smoking gun. The researchers had to prove it, right? So they designed this absolutely brilliant experiment to see if the mitochondria were really the cause of the problem. This really is the critical question. Is the mitochondrial problem just one of many things that decline with age, or is it the first crucial domino that knocks all the others down? So here's what they did, and it's so clever. They started with perfectly healthy eggs from the younger group. Then they used a drug to temporarily disrupt their mitochondria, to basically hit the pause button on their energy production. They were essentially aging the powerhouses for just a little while. And then they just watched to see if the eggs could still mature properly. And the result was just wow. After just that brief disruption, the maturation rate for these young, healthy eggs absolutely tanked. It went from over 86% all the way down to 39.5%. Think about that for a second. The only thing they changed was the energy supply from the mitochondria, and that one tweak made these young, healthy eggs perform even worse than the naturally older ones. I mean, that's about as close to a smoking gun as you can get. It proves that mitochondrial health isn't just a symptom of aging, it's a direct cause of declining egg quality. So after all the observations and that killer experiment, the verdict is in. We can finally connect the dots and get a much clearer picture of what the biological clock really is. It's the mitochondrial clock. It all comes back to that energy-guzzling marathon. To mature properly, an egg needs a huge burst of fuel. And if its powerhouses, its mitochondria, are fragmented and weak, they just can't supply it. It's like the cell literally runs out of gas before it can cross the finish line. And the researchers who did this study, they summed it up perfectly. They said that poor mitochondrial metabolism, basically poor energy production, gets in the way of the egg's ability to properly divide its chromosomes. And that is a huge reason why we see lower maturation rates in older women. So really, this is the main takeaway. The biological clock isn't some vague, mysterious thing. In a very real sense, it's a mitochondrial clock. The ticking we're all talking about, it might just be the sound of thousands of tiny cellular engines becoming less efficient over time. Which, of course, leaves us with a really exciting and powerful question for the future. If an egg's energy level is the key to its quality, what does that mean? Could we find ways to protect these tiny powerhouses, or maybe even support them? This research isn't just about solving an old mystery. It's about opening a door to a whole new way of thinking about fertility.